Let's look at web service architectures. Today we are going to learn how to set up and manage your web applications using Docker, and this is going to be foundational if we want to ever understand and design microservice architectures. Allow me to introduce the URL, or the Universal Resource Location. If you have ever browsed the web, you might be familiar with this kind of string. In fact, this string is the basics for every web request out there. It typically starts with either HTTP or HTTPS. This is because HTTP, or Hypertext Transfer Protocol, is the protocol in charge of transferring web pages between a server and a client. It also manages the transference of meta information. HTTPS just adds a security layer, encryption, on top of HTTP. Then we might find the domain. Domain is just an entry in a DNS, domain name service directory, that points this name to a server which is then listening on a port, which we specify this way. This port is optional, because if we are using HTTP, it is assumed that we are using port 80, and if we are using HTTPS, we are using 443. Finally, the URL might include a path. This path works exactly the same as the file structure in a computer, where you have folders, folders inside folders, and then finally the file you want to access. In this case, the folders and the file might be your service. In past videos, we've seen how to run your Dockers, and we've seen that when you want to create a container, you specify the container, the image, and then map the port that the image specified that is exposing to a port that your host computer can listen to. This works out of the box. This is how we are instructed to use Docker. However, if we want to set up more than one web service in our server, only one of these services can use the official port. Imagine going to Google, and if you want to access the Gmail service, then you have to remember which port this service is at. Even worse, each of these services have to be self-managed in terms of security, or whether they are deployment, production, or staging environments. So how can we improve this? We can use a host gateway. This is just setting up a web server inside the host computer that receives all the requests from the standard ports and then redirects them to the different services. This way we can set up things like reverse proxying, by which we attach each service to a different path in the request, or we can use virtual hosting, by which we attach each service to a domain, always when the domain points to the same server. This allows us to manage as needed. So if we add a new service, we can set up this new service, whether it's a path inside a virtual host or other combinations. However, this option is not portable. The configuration for our web server works for our host computer, but might not work for other host computers. And finally, if we have a highly dynamic container network, where containers are started and stopped dynamically, it might be complex to dynamically configure the web servers in order to adapt to this changing configuration. So how can we improve further on this? We can deploy the web server inside Docker, our Docker network. In this case, this is typically called the API gateway. The API gateway is in charge of receiving the requests, the web requests, and then redirecting them to each of the service. Again, we have all the benefits of reverse proxying, configuring services in the paths, virtual hosting, configuring the services in different virtual hosts. We can manage security centralized as all the requests pass through this component. We can port our configuration because it's inside this network, and we can model that network and then deploy it in another host. We have dynamic configuration. In most cases we can deploy, and we have seen such how to connect containers with the Docker engine. So in this case the container can subscribe or can react to changes in the Docker environment. And then we can set up dynamic environments in the same host. Imagine if we have three domains, one for production, one for testing, another for staging, all pointing to the same computer, and then we can have this API gateway decide which services is each environment. Or we can have a hierarchy of API gateways and networks, each defining the different environments. Finally, let's look at some list of API gateways that we can use as the component that redirects the web requests. First, we might think in standard web servers. In fact, some of them have specific Docker plugins in order to have that dynamic configuration. This is the case of KD2 or Nginx. Nginx, in fact, there is an implementation called Nginx Proxy that has many derivatives, which typically what they do is that they set up a virtual host for every container who has the environment variable virtual host, and the value of this environment variable is the DNS name that we want it to respond to. Some variants such as the IUFAN auto proxy also auto-manage the TLS certificates, the X509 certificates that are used for the HTTPS, and enforce the usage of secure protocols through the policy HSTS. We might also find specific API gateways for microservice architectures, such as Express Gateway or Kong. In the case of Kong, it's more security oriented, but in these cases what we have is environments that allow us to very fine-grained select the APIs, the paths, and the virtual hosts that we want the API gateway to respond to. There are, of course, many more, and you can find the link down to an article that lists them.